Okay. So are we ready to start the quiz?
I'm still bringing mine up. Okay, I'm ready. Welcome back.
Okay, I'll read number 3. So it says, given the linear regression equation, y equals 2.0 plus 1.5x, what is the y-intercept? And it'd be 2.0, right?
Yep,
Yeah,
that's what I
first
thought.
one.
Okay, I'll go next. Given the linear regression equation y equals 2.0 plus 1.5x, what is the slope? It's 1.5.
Yeah.
Mm-hmm.
I'll
Does
read
someone
the
want
next
to?
one.
Okay.
Given the linear regression equation, y equals negative 3.0 plus 0.25x, what is the predicted value of y when x equals 16? And that is 1. What I got.
1. I got
Okay, I'm
7.
going to try to solve it first.
I got 1 as well.
Oh, how did you guys do the problem?
So
So I multiplied 16 by 0.25,
Uh-huh.
and that was 4. And then you add the negative 3 plus the 4.
Oh, I think I didn't do the negative 3. Okay.
And that would make it
So
7.
positive. Yep. That makes sense. Okay, so 1. This is why I'm glad we do group.
I know. Oh, yikes. Okay, I can do the next one. For the next 7 questions, use the data file math self-efficacy. Be sure to use the confidence data for the explanatory variable and the score data as the response variable. Make a scatter plot of the math self-efficacy data of the 3 data shapes, introducing the reading which shape best describes these data. Well, now I got to do it, so.
So this is the same data we used yesterday, except before how we pasted it, just exactly how it looked. They had it do the opposite this time.
Okay. I still have to bring up that Excel program. Sorry guys, it's taking me a minute to put my stuff in.
You're fine.
Oh, no.
Does anyone have any idea for the shape?
I said hot dog.
I said hot dog too.
Yeah.
So where did it talk about the shapes in the reading, or did it?
Yeah.
Yeah, it's only in the readings, not in the videos.
Okay, which I must have missed that. But
Well, I don't even do the readings anymore, so I had to go back.
You don't.
I just do the videos, and then I kind of skim over the readings because I learn better with the videos.
yeah.
I just can't do it with just the book.
Yeah, it looks like a hot dog shape to me when I look in the chapter. Yeah.
Okay.
Okay. So question 7, does someone want to read that?
Sure, I will. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? I put simple linear regression is appropriate for these data.
That's what I said.
And is that because it's kind of semi-straight?
Yeah.
That kicked me off. Okay. Are we still on? I got kicked off there.
Oh.
So
Are we still on
just
6?
finished question 7.
So it was hot dog shape though?
Yeah, it was hot dog.
What's the difference between hamburger and hot dog shape?
So hot dog is kind of in a straighter line, and the hamburger, it's more random and scattered.
And then I'm assuming the banana just has like a curve to it.
Yeah.
Mhm.
A non-linear pattern.
So is this a simple linear regression is appropriate for this data?
Yes.
Yes.
For the first one? How many observations are in the data?
would it be 140? Is that like? Oh,
See, I thought it was 142.
well,
So
because we have like explanatory variable that takes up 2 cells, and then the t-test for linear takes up 1 cell. So the data doesn't actually start until the 4th cell. So it actually, I think, would be 138.
Oh.
So where are we looking to get that? I wasn't sure.
Did you just have to scroll down?
Yeah,
Yeah.
I just looked at the data files and looked at the number, how many there were.
Yeah, I just didn't
still
know if
don't
there was a spot like in the t-test for linear regression or not.
I know, I'm wondering that too, if there is. It's probably there somewhere.
I just don't
Although
see
I'm not seeing a number near that number.
I think it's 139 because on the I don't know, the math self-efficacy thing, it goes from 1 to 140, but then you don't count the top line. I think it's 139.
Yeah.
Yeah.
I don't know. I mean,
Yeah, that's what I think too.
Right.
It's 139.
Okay.
Yep.
what is the y-intercept? That would be B. So is 1.296. Is that right?
That's
So wouldn't that be the 18.690?
what I put.
Yeah.
Where'd you get that? 18?
Where did you get
I see
that
the
at?
1 point.
In the Excel spreadsheet.
I still don't see
There's
that.
so there's like 3 different sections in the Excel spreadsheet. It's in the center section at the very front of it, the very beginning. There's it says model, and then it says y-intercept, and it says slope.
Mhm.
Mm-hmm.
And then the
I see.
B number is the y-intercept.
Yeah.
And I have
Okay.
1.296.
That's what I have too.
So did you guys put the because you were supposed to put the Let me look at this really fast.
Was it in the wrong order?
The confidence rating mean was supposed to go in the X, and then the
Yeah.
score was supposed to go in the Y.
Yeah, so like how yesterday it didn't really seem to matter
Okay.
where we put those in, but today
Okay.
they specified.
Today it does matter, huh?
Mhm.
So the confidence rating mean goes in the first column, right?
Yes,
Mhm.
so it would
Yeah.
start with
That's
the
what I messed up.
4.34,
Yeah.
and then the
Okay.
Y would start with 50.
Well, let me fix that then.
Oh. All tricky today.
I'm glad we caught that now because I'll pay more attention to that in the test now. I mean,
Yeah.
yeah, that will come up. Okay, now I got 18.690.
Yeah.
That's what I
Okay.
got.
Yeah.
Thank you for pointing that out.
18.69.
You're welcome. I'll read the next one. Question 10, what is the slope? And for that one, I got 12.695.
That's what I got. Okay, I'll read the next one. What is the predicted value of y when x equals 4, round to 3 decimals? And I got 69.47.
That's what I got.
Okay.
I'm still trying to switch them around.
Oh, I'm sorry.
Oh, that's okay. My stuff takes forever.
So what'd you get for 11?
For 11, I got 69.47.
Okay, that's what I got.
Oh, sorry, guys. Hold on a second.
No, you're fine.
Fine. You can only work as fast as the technology will let you.
Yeah.
Okay, 18.69, 12.695,
Mm-hmm.
Mm-hmm.
and then what was the last question we could solve for?
So that
69. Oh, go ahead.
69.47. And do
Where
you
did
know
we
how
see
we
that?
get that? So it's not on the Excel spreadsheet, but we put it
Oh,
into the equation of the y equal, or the y hat equals the BO plus B1 times X. And
But
so it'd be set up 18.690 plus 12.695 times 4.
And that came up to
But-
what?
69.47.
But you can do it in the Excel, and for the homework, you have to do it both ways.
Oh,
So,
really?
yes, because
How do you
I
do
was
it
like,
in the
what
Excel?
do you do? So in Excel, under model, like in that second line, there is an X with a blue box, so you can change that number. So you would
Oh.
just add 4, and then next to it is predicted. And those two numbers are always going to be different. So yeah, on your homework, you'll see that
Oh.
when you calculate it by
Cool.
hand, it's going to be different from Excel.
Cool trick.
Why would it be
Okay,
different? So
so-
can we put that in there?
Yeah,
Well,
because this question actually, I think that's what we do have to do. Because this question asks for 3 decimal, round to 3 decimal places.
Oh.
Oh,
So we would have to do that.
okay.
I'm glad you
So-
pointed that out. Otherwise, we would have gotten the question wrong.
I only know because I was doing the homework this morning. I was like, how do I do this both ways? And I figured it out. But yeah, you'll see on the homework, every single question, you have to do it both ways.
Okay.
So wouldn't it be just if we rounded it 69.470?
Oh, yeah.
Well, to 3 decimal places, I don't. What is the calculation on the
We'd be rounding it to the third, so it'd be like a 90 there, so it would just be 469.
Yeah.
Oh,
Yeah,
469?
if we're rounding it to 2 decimal places, then it would be the 47.
47.
Oh, okay. Gotcha. Okay, so for that one, we'll put 69.469.
Yeah.
Okay.
Okay, I can read the next one. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? You just put 6 in?
Yeah, I think so. So I got 94.859.
That's what I got.
Yeah, that's what I got.
Okay, I can read number 13. How many explanatory independent variables are present in simple linear regression? Is it just one?
Yeah.
I don't know.
And we're saying one somewhere.
So how do we know this one?
I think it said
It's
something
just-
in the book.
Oh, did it?
I think so.
Okay. Okay.
But
Are they both one? Answers are 1, right? The 1-to-1 thing.
Yeah.
Okay.
Okay, so it's 1.
So 1 for 14, then 2?
Yeah.
I don't know.
I think in a simple linear regression, you're just looking at how one thing affects one other thing, and that's it.
Mhm.
Oh, okay. When you say it like that, that makes sense.
Okay, I'll read the last one. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. What is the response variable?
Size of hat.
Yeah, it's the size of the hat. That's what I think too.
And then I think it's the third one down. No.
The response
Yeah.
variable, that's what they're trying to find, right?
Yeah.
Yeah, which is
Yeah.
X,
Supposed to be
right?
the first one, right?
The response variable is
Oh,
y.
the response variable is Y. Yeah.
Mhm.
Yeah, I can't tell if it's the first one or the third one.
It's not the third one because
It's not being used to predict. It's the one being predicted.
Okay.
Okay.
Yeah.
sounds right.
Okay.
Does someone want to submit it?
I can submit
it.
it.
We decided it was the first one.
Yeah.
Oh. You want me to submit it?
Sure.
Okay. Okay, 100%.
Woo.
But can you guys really quickly explain to me how we did number 8? I don't think I get it. Did you just look at the data files?
That's what I did, yeah.
Is that the observation? Oh, yeah.
Yeah,
Yeah.
that's
Yeah, that's
observation.
all.
Yeah, it's basically the end or like the sample number.
Okay. Is that a number on the?
It's how many
No.
dots there are on the scatter plot.
Yeah, does it say that, or can you just, because we just looked at like the data and how many rows
That's
of
what I
data we
did,
had.
yeah.
Yeah, I guess why I'm confused is because for me it's showing like 142 observations.
Yeah,
So what
that's
did you
because
subtract?
so the one is a t-test for linear regression, so that's not an observation. 2, 3 are explanatory variables or whatever. So we just subtracted 3 from the 142 because those aren't observations.
Okay.
If you look at the cells.
Okay.
Does that make sense?
The numbers don't start till cell 4.
Yeah.
Okay.
It's easier to
I
look
see
at.
what you're saying. Okay.
It's easier to tell from the actual data file
Yeah, it is.
because it's
Okay.
you just take away 1.
Yeah, that's what I
Yeah.
did. It's way easier.
Okay, that makes sense now. I'm like, wait, how did we get that number? Yeah. It's better to look at the data files. I agree. Okay.
I feel like there should be a spot on the
Yeah.
on the spreadsheet to find it because it has in the past, but I guess it doesn't for this one.
Okay.
Okay.
All right.
Good job.
I'll get that sent to you soon, Missy.
Okay. Yeah, no problem. Whenever.
And then who's it for next week?
Me. I'll set everything up, I think.
Okay.
Okay.
Right.
So Dan, do we have to attach ours together, or do I turn mine in separately from yours? Do you know?
I think they have to go together, so
Okay, so I'll get yours and then I'll attach mine to yours then and send it in.
and then you'll submit it. Is that okay?
Yep, totally fine. Okay.
Okay.
I'll try to send that out to everyone so everyone can review my math. And,
Sounds good.
Awesome.
Do you want to see mine before I turn it in, or?
I think you're
Okay.
supposed to get
Okay.
everyone's approval.
Okay, so I'll send it out. I'm not sure if I'll be able to get to it though till later in the week, but
That's okay.
That's okay.
that's okay.
No
Okay.
worries. Okay, have a good week, guys.
All right, thanks. You too.
All right.
Bye.
Bye.
See ya.